so that you continue with us. So we say that when you are naming, the last name to be written is a parent name, which indicates the number of carbon atom in a chain. Now, and you have such a compound, and you want to name using the Iupac system of nomenclature. So the first thing you do, you identify the longest chain, okay? And in this case, the longest chain, if we consider this to be carbon 1, and this to be carbon 2, and this to be carbon 3, 4, 5, 6, and 7. How about if we take this direction? Is the carbon chain going to be the same? So if this is 5, then this one is 6, and this one is 7. So it becomes the same. And if we take maybe this, now this is days. If we take maybe from here and we go this is still days. So now our longest chain is this, okay, with 7 carbon atoms. Now after identifying your longest chain, and the longest chain has 7 carbon atoms, in nomenclature, if you have 7, then you become hept. We name you as hept. Hept means 7 if you remember your primary. But since it is an alkane, then it becomes heptane. Now, so this is going to be our parent chain. Now, what is remaining is attaching the groups. And the groups, we have this group. Let me first erase. So for the groups, you have this group, okay, and you also have this group and this group. So those are the 3 groups. However, 2 of them are identical, are the same, okay, and this one is different from the rest. Now, so after identifying the groups, and the groups are, it's a methyl group. Why methyl? Because it has 1 carbon atom, so that is meth, but we add YL to name it as a group. So it is a methyl group. Even this one is a methyl group. But this one, since it has 2 carbon atoms, then it becomes an ethyl. Eth means 2. Now for those this is your first lesson, you're going to watch the videos and get to the same level with us. Okay? If you don't get it, if you don't get some things, then you still come back to me. I will explain in details. So that is eth, and then this one therefore becomes the ethyl group. Okay? So now after identifying your groups, the next thing is identifying the positions of the groups. And the positions are these carbon atoms. And if we count from left is this side to right, okay, left to right, the groups are attached on carbon number 3, because this is 1, 2, 3. So the groups are attached on carbon number 3. So this is one group, it is attached on carbon number 3. Another group is also on carbon number 3. And then another group is on carbon number 5. You see? 1, 2, 3, 4, and 5. So it is on carbon number 5. So now if you add this will give us 11. I'll tell you why we are adding. Now, if we count, now you don't know which side you don't know which carbon should be named as carbon 1 and which carbon should be named as carbon 7. So now, doing what we are doing, it is what is going to help you determine which carbon is going to be named as carbon number 1. So if you count from right to left, this one is going to be 1, 2, 3. So it will be named, this one is going to be 3. So our ethyl group is attached on carbon number 3 and 4, 5. And the methyl groups, one of them is on 5, and also another one is they are all on the same carbon, so it is also on 5. So if you add this one becomes 13. Now the Iupac says the side that should be considered, it is the side that gives you the lowest sum, and the lowest sum is 11. So we shall consider the carbon that is on the left hand to be carbon number 1, and the carbon that is on the right hand to be carbon number 7. So we shall consider this side. So therefore, when we are naming now we know that our methyl groups are attached on carbon 3, and the ethyl group is attached on carbon number 5. Okay? Yes. So therefore, now when the next thing we are remaining with is the alphabetical order. This is methyl, and this is ethyl. And E comes before M in the alphabetical order. Okay? So now you are done. After identifying all that, the rest is writing the name. And when you are writing the name, you first write the position. Okay? You put a hyphen, and then you write a group. Okay? And the group is ethyl. Okay? So this means that the ethyl group is on carbon number 5. Okay? Then you put another hyphen, then you write the methyl groups, but there are 2 of them, and the whole of them are attached on carbon number 3. So you write 3 with a hyphen. But because there are 2, then we shall put di to represent 2. Okay? And then methyl. Okay? There are 2 methyl groups. Okay? So 3 dimethyl. And then after writing that, the rest is writing the parent chain, which is heptane. And you write it as one single word. Okay? Heptane. And so if you do this, then you'll be good to go. So this is how we name this. This is the Iupac name, okay, of this compound. Now for the new members, I've tried to summarize whatever we have studied up as far as nomenclature is concerned, naming this. Okay? Yes. Can you try to name this? So that is your name. Can you try to name this? For the new members. For the new members, try to name this. And I know it might be hard. Sorry for this line. So you have the C here. And then you have the CH here. Can you try to name this? Now when you are naming, you drop your answer in the chat box. It's from carbon 1, 2, 3, 4. So it has 4 carbon atoms. And 4 is named as beauty. I talked about all this in the previous video, so you have nothing to worry about. So it is named as beauty. And since it is an alkane, then alkanes are named as, you add this suffix ane. So it becomes butane. But now we need to show the position of our group. Okay? And our group is a methyl group. Okay? Our group is a methyl group. Now, since it is a methyl group, we need to find which carbon atom is it attached. Okay? And if we count from this side to this side, from left to right, the methyl group is attached on carbon number 3. But if we count from right to left, the methyl group is attached on carbon number 2. So we take the side that gives us the lowest sum, the lowest locant. Locant means that carbon atom where a group is attached. And in this case, the lowest locant is 2. So we shall count from this side to this side, and this therefore becomes carbon 1, and this becomes carbon 2, and this becomes carbon 3, and this one becomes carbon 4. So therefore, when you are naming it, you write a 2, and then the group that is attached on carbon number 2, you put a hyphen, so the group is 1. So you don't write mono, just write the group. So it becomes 2-methyl, okay, and then the parent chain, and the parent chain has 4 carbon atoms, so it becomes butane. So it is as simple as that. So I discussed all this in details in our previous videos. Now how about in cases where there is a functional group? Okay, for example, this case that is coming. So if a multiple bond is present, and a multiple bond can be a double bond, and a double bond, we call this an alkene. Okay, and if you watch our introductory video that has the course outline of organic chemistry, you will see what alkenes are. I talked about them in details. Or if it has a triple bond, and for triple bonds we call these ones alkyl. Okay, so if it has a triple bond, it is an alkyl. If it has a double bond, it is an alkene. If the double bond is present, then the parent chain or the longest chain identified must contain the double or triple bond. For example, you can see this. You can see this. You can count, you see, if we count from left to right, if we consider this, this will be carbon 1, this will be carbon 2, this will be carbon 3, this will be carbon 4, this will be carbon 5, and this one will be 6. Okay? Good, you keep that. Let me change some pen. If we count from here, oh, this pen is not favorable for the white. For white. If we count from here to this, okay, this will be 1, 2, 3, and then this is 4, and then this is 5, and then this is 6. Is that okay? If we count from here to here, okay, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So in other words, it is all 6, 6, 6. Now here you can take any side, okay, since it is all 6, 6, 6. But however, in fact, is this 6? This is 1, 2, 3, 4. Okay, then 5, 6, and 7. So this one is 7. Okay, so this one is going to be our parent chain. But however, even if this was 7, maybe if you have, maybe this is a 2, and this is another CH2, assuming this was our longest, okay, and you have 1, 2, 3, 4, 5, 6, 7, 8, and this was our longest chain, you cannot take this chain. Why? Because you have a double bond here. Okay, your parent chain must contain a double bond or a triple bond. Is that okay? And the double bond or a triple bond must be given the lowest number. Okay, the lowest local. Okay, yes. So let's see how we can name this together. So we are going to take this as our parent chain. Okay, and so this one becomes carbon 1, this one becomes carbon 2, 3, 4, 5, 6, and 7. Okay? Then, so this will be our parent chain. Our parent chain has 7 carbon atoms. Then therefore, this is a group that is attached on our parent chain. And the group is, yes, the ethyl group. Okay? Ethyl group. Now, after identifying a group, the next thing is to identify the position of the group. But now, since we have a double bond, the position of this group is going to depend on the position of the double bond of this bond. And so how are you going to do it? Now, if you count from this to this, the double bond is going to be on carbon number 3. That is if you count from left to right. It is on carbon number 3. But if you count from right to left, that is from here to this side, the double bond is going to be on carbon number. This is 1, 2, 3, 4. So it is going to be on carbon number 4. Okay? But we take the number that gives us the lowest locand, the lowest position of the double bond. So therefore, we shall take 3. So we shall count from this side, from left to right. Now, if our double bond is on carbon number 3, then our group here is going to be attached on carbon number 4. Okay? Yes. So therefore, when you are writing, therefore it becomes 4. Then you put a hyphen. Then you write the group, and the group is the ethyl group. Not so? The ethyl group. And then the parent chain has 7 carbon atoms, and 7 is written as hept. You write it as one word, hept. But since it has a double bond, then in alkenes, they are named as derivatives of alkanes. Where there is, for example, where there is ANE, because alkanes are named as, you add this suffix ANE, you replace this suffix ANE with the suffix EN, something like this. So if it was an alkane, this would be heptane. But since it is an alkene, then we shall substitute Ne with Ene and becomes heptene. But now, however, our double bond is not on carbon 1. Okay? It is on carbon 3. So you have to include that. And how do you include it? You put a hyphen, okay? Hept, and then you put the position, then you put another hyphen, okay? And then you write the word in. So it is as simple as that. For ethyl, hep 3 in. Is that okay? And at least all of you must. It is CH3, CH. The concept is 1, so you have the H here. Okay, let me not confuse the new members. I was going to put it behind. It is the same thing, but for the new members, let me write it. So it is CH, and then you have a double bond here. You have C, then you have CH3. Okay, let me put 2. Put 2. So you try to name this. You have just 2 minutes, and I should find the name. And if we count from here, let me get some different pen. Let me get a yellow pen. If you get 1, 2, 3, and 4. And so if you count from here, that's 4. But if we count from here, okay, like this, Then that becomes 1, 2, 3, 4, and then 5. Okay, so they are just 5. That's pretty good. Oh, somebody can also count like this, but now the rule knocks you out. Okay, if you count from like this, it becomes 1, 2, 3, 4. 4. But the rule knocks you out. You are neglecting this double bond. Okay, so by all means, your parent chain must contain a double bond, and you should also find the longest chain, though the longest chain must contain a double bond. So in this case, the longest chain is going to be this. Okay, now after identifying the longest chain, the next is to identify the position of the double bond. And if we count from left to right, left to right, the double bond is on carbon number 2. 1, 2. It is, you take this carbon atom that is on the left hand side, okay? The very first carbon. So it is on carbon number 2. But if we count from right, okay, to left, then the double bond is on carbon number 1, 2, 3. So it is on carbon number 3. But we take the lowest locant, which is 2. So we shall count from left to right. So this is going to be a carbon 1, and this is carbon 2, this is carbon 3, this is carbon 4, and this one is carbon number 5. So now therefore, our methyl group is attached on carbon number 5, number 3. So therefore, when we are naming, it is 3 first, then hyphen, then you write methyl, okay? You write methyl, okay? Because it is a methyl group, and a methyl group is attached on carbon number 3, and then the parent chain, and the parent chain is 5, okay? So, and 5 is paint. You remember the pentagon in P7? Yes, 5 is named as paint. If you endeavor to watch our previous videos, okay? All these ones I talked about. So 5 is paint, so it is paint, paint, but it is our alkene, okay? Because it has a double bond. So therefore, and the double bond is on carbon number 2. So you put a hyphen, okay? And then you write the 2, and then another hyphen, and finally you write in. Is that okay? If it was a triple bond, maybe 1, 2, 3, instead of in, now we substitute in with y and e. You can say yain, you can say wine, ch. Let me give you this. Can you hurry up and name that one? Let me also give you this. So here it depends on how you, the more you name, the more you master.
Seven.
Okay, let me make life a bit hard. So you name these ones, these two. Hurry up, please, hurry up. Let me check the chat box as if somebody. Okay, it was some network glitch. which is okay. So you name these two. Hurry up. Yes, you named it right. It is 2,2-dimethyl propane. And how do you get it from? You consider the carbon chain. So if we count from this, if we consider this, it is 1, 2, 3. If we consider this, it is still 1, 2, 3. Then the rest are groups. If we consider this, it is still the same thing. Okay? It is 1, 2, 3. Then the rest are groups. Similarly, when we consider this, so whichever way you do, here it is the same thing. 1, 2, 3. So because of that, you just consider which the side that favors you. Okay? And for my case, I'll consider this side. Okay? I'll consider this. This as my parent chain. Then the rest are groups that are attached on the parent chain. And the groups are two. They are all methyl groups. And since they are all methyl groups, and all groups are attached on carbon number 2, then I'll just write 2, then comma, then another 2, then hyphen, then I write di. Why di? Because they are 2. Okay? And which 2? Methyl groups. Dimethyl, dimethyl, meaning this one and this one. Okay? Yes. Now, the parent chain is 1, 2, 3. The parent chain has 3 carbon atoms. And since it has 3 carbon atoms, then that one, the 3 is named as prop. Prop means 3. In Latin, I think, yeah, it's Latin. But since it is an alkane, it doesn't have a double bond, okay, nor a triple bond, then it is an alkane, and alkanes are named by adding suffix ane, okay, on the stem name. So we shall just add ane here, and it becomes propane. So basically that's how we shall name this. So it will be 2,2-dimethyl propane. But however, this one, for him, it wasn't correct, and I'll show you why. So we just said 4 and then die. But it's even if it is on the same carbon, you say 4, 4, die. But still, it is not carbon 4. Why? The double bond is here. Now it is the double bond that will give us the position. So if we count from left to right, left to right, the double bond is on carbon 1, 2, 3, 4, 5. So the double bond is on carbon number 2. But if we count from right to left, okay, then the double bond is on carbon number, this is 1, this is 2, this is 3, this is 4, and then this is 5. So if I count from right to left, this is right, this is left, the double bond is on carbon number, yes, 3. Okay? So therefore, we shall take left to right. Okay? Good. Now, after identifying that, then the rest is you identify the groups. Okay? And the groups, there are 2 methyl groups, this one and that one. Okay? And the 2 methyl groups are attached on carbon. Since we have taken this as our carbon 1 and this as our carbon 6, then it is on carbon number 4. 1, 2, 3, 4. So after identifying the groups, then the next thing is writing the name. And for you, you made a mistake. You just wrote 4 and then you put die. No, you write 4, you put comma, you write another 4. That comma is not appetizing. So 4, comma, 4. Okay? And then you put hyphen and then you write die. dimethyl. Okay, why dimethyl? This one and this one. Now the rest is 6, and 6, you remember in primary it is hex. Okay, a hexagon has 6 sides, so also this is hex, so you write your hex. Okay, it is one word now, hex, but now the rest is the position of the double bond, and the double bond is on 2, so you put a hyphen, you write 2. You put another hyphen, and then you put E-N groups. Now, for those who didn't attend our first lesson, we say that a functional group, it's an atom or groups of atoms that are attached, okay, on an organic compound, which determines the overall physical and chemical properties of that compound. For example, you can see, you can have this, a compound where you have a halogen. For example, you may have this as our alkane, okay, CH3, CH3. I know you studied this in O-level. And which this is? Yes, that is ethane. But when I remove one hydrogen, okay, and I substitute it with maybe a Cl, okay, maybe a Cl, something like of this kind. Now this one changes, okay, and the reaction of this are totally different from the reaction of ethane, just CH3, CH3, okay, they are different. So because of that, it is just one atom that is bringing the difference, okay, then this atom becomes a functional group. I may add, instead of this, I remove one hydrogen, and I add the OH group, the OH. Now it could be an atom or groups of atoms. Now this is one atom, but this is a group of atoms. Now because of this OH, you will change this one does not behave as this, and neither does it behave as this. So this atom or groups of atoms that determine the overall physical and chemical properties of an organic compound is what we call a functional group. Now, for example, this is your ethanol, the sanitizer that you take, and this is chloroethane. We are going to see how they are named. Now, in case you have there those functional groups, and if you have the halogen, for example, chlorine, then it is named as chloro. Okay? If it is a fluoride, it is named as fluoro. If it is a bromide, it is named as bromo. And if it is iodine, it is named as iodo. For example, we can name this together. We might have CH3, CH2, Cl, Cl. Now this one, this is the Cl. It was just a keyboard mistake. So now this one, it is named as chloro, 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 oh, chloroethane. It is one word, not two words. Don't separate the words. Why ethane? Because it has two carbon atoms. Okay? And why chloro? Because it has a chloride atom. Can we name this? CH3, CH, and then you have the Cl, okay, and then CH3. Can we name this? Yes, that's good. This one is going to be 2. Why 2? Because our functional group, our chloride, is on carbon number, yes, It is on carbon number 2. So that's why it is 2-chloro. And then you put a hyphen, okay? And then you write your chloro. And then the stem name. And this one has 3 carbon atoms, 1, 2, 3. So it becomes prop, but it is an alkane. So therefore it becomes propane. So it is basically as simple as that. So even if you have any substance, you can name it. And I'll give you more. If you have the double bond or the triple bond, okay, then if it is a double bond, the double bond is named as in. We have named some. If it is a triple bond, then the triple bond is named as wine or yain, and we have named some. If you have this group, okay, are you seeing the carbon and then the H? This is an aldehyde. Okay, we saw functional groups. You can go and check on the videos, okay? This is called an aldehyde. And so this one is named as anal. Okay? For example, if we can name this, in this it is CH3. So this is ethane. So ethane. But if I replace the 2 hydrogens here with the oxygen, okay, and I form this, I replace the 2 hydrogens with oxygen, and I form this and I put the H here. So are you seeing this? I've replaced the 2 hydrogens with oxygen to form this. Then this one becomes ethanol. I write the word eth and then I add anal. Okay? So depending on the functional group that you have, okay, it will determine the name. If you have this is a ketone. If you have such a compound, and then the ketones are named as on. Okay? For example, you have this CH3, that is the simplest ketone. However, don't worry, we shall study all these functional groups as topics. So you have CH3, CH3. Okay? So this one is named as, since there are 3 carbon atoms, 1, 2, 3, that one becomes prop. So propane, that is propane, and then you add on, so you put propanone. Okay, so it is as simple as that. If you have the OH, OH is named as O. Okay, that's why ethanol is named as ethanol. Ethanol is named as ethanol. Why? It is CH3, and then CH2, and then OH. So basically it is as simple. Okay, it's okay. Yeah, this is the pen. Now it is 1, 2, 3. Now it has 3 carbon skeleton. Okay, the 3 carbon atoms. But however, that carbon atom with a functional group, and the functional group is the OH, becomes carbon 1. So this is therefore carbon 1, this is carbon 2, and this is carbon 3. Okay? So therefore this is just, now also you named OH Okay, OH, you named it as anal. No, it is not. We name the OH as OR. This is an alcohol. Now the difference here, I want to stretch the bond, the CH. I want to stretch the bond. So this bond is with this carbon atom. Okay, this carbon atom, it is bond. This one is bonded with this, so this is the bond, and then it has two hydrogens. One is here, okay, and another one is here, and then it has the OH. So if I stretch the bond, it is like this. But for aldehydes, where to write anal, it's like this. It will be written as this CH. I'm writing that carbon skeleton, CHOH. So if it is written like this, it means the O is here and then the H is here. Okay, so now these two are different. Are you saying this one just, so this is an OH and so this is an alcohol, whereas this is an aldehyde? Maybe this is the carbon that is, so this is an aldehyde. So what is given in the question is this. Okay, and that carbon atom with a functional group is the one that is named as carbon 1. Okay, so therefore this one becomes propanol. You don't need to write the 1. Okay, propanol. So as simple as that. Then for this one, okay, the OH is on carbon number 2, but it is 1, 2, 3, 4. Now you can't count from here to here, because if you count from here it will be 1, 2, 3. The OH will be on carbon number 3. But if you count from left to right, the OH will be on carbon number 2. So we shall take this direction. So therefore our OH is on carbon number 2. But it is 1, 2, 3, 4. So it is but. But. Then you put a hyphen. Anyway, this is butanol. So you write butan. Okay, butan, and then you put a hyphen, then the position of the functional group with another hyphen. Okay, and then you write or, and this or is the one that shows this OH. So this one therefore becomes butan 2 or. Is that okay? Yes. Then finally, with this, the carbon skeleton is this. Okay, so therefore this is a group that is attached on the carbon skeleton, and this is another group, but this is a functional group. So this one is taken as an alcohol, and this is just a group that is attached. So when you are naming, it becomes 2. Okay, and then this methyl, because it is attached on carbon number 2. Okay, so 2 methyl. Okay, and then 1, 2, 3. So that is 3, that is prop. So it becomes prop. Propan. Now since it is an alcohol, now when we are naming alcohol, they are also named as derivatives of alkanes, where the ANE in alkanes, we just remove this final E. Okay, and replace it with O. That's why it is methanol. It is methanol. It is ethanol. From ethane, it becomes ethanol. From propane, it becomes propanol. Okay, propanol, and so on and so on. So even here, it is propane. It is supposed to be N, but because it has this functional group OH, then we shall remove E and put OR. But the functional group is on carbon number 2, so we indicate that by writing it here. Hyphen, then 2, then O. So basically, that's how you are supposed to name these ones. So we are going to stop here today, but go and watch the previous videos. All of you, watch the previous videos so that nomenclature becomes part of you. Even if you are dozing, nomenclature becomes part of you. Now for somebody, Edwin is saying I'm lost. From where? So I encourage everyone, okay, to watch the previous videos before the next lesson, okay? Before the next lesson, watch the previous videos. Where you get confused, always come back to me. I'm always a call away, a text away, or come back to me. If it is to schedule your own lesson, okay? Maybe you can schedule a simple lesson of 30 minutes and we discuss about what confused you in a video. We can do it, okay? So feel free to contact me, feel free to always come back. So now, somebody's saying that they cannot see the videos. Let me show you the videos. Let me log in as a student and show you where the videos are. However, I uploaded some last night. I haven't added them to class, but I'm going to add them just now. So I'm logged in as a student now. Now if I go to classroom, if I go to classroom, the classroom is here. The classroom is opening. The chemistry classroom. The biology is the same. There are videos too. Even the chemistry is the same. So when you open, now I'm logged in as you. This is what you see. Okay. So when you tap in, just go to classwork. Okay. And when you go to classwork, go to organic chemistry. Okay. Then recordings from the previous lesson. Now this is for A level. No, this is what we talked about. This is the preview, what A level organic chemistry is about. Then we talked about hybridization, because for you to understand bonding, to understand why carbon forms a maximum of 4 bonds, then you have to know this concept of hybridization. Okay, so first watch this, and then after hybridization, then you shall watch bonding. And this was all one lesson. Then I'm going to add videos of the next lesson that connects to today's lesson. Okay? Yes, I'm going to add it. I'm going to add it here. So that by the next lesson, make sure you would have watched all these videos. Okay? These ones, they try to watch them, jot down, summarize, okay? And after summarizing, you can read through, you have the notes. Okay, where are the notes? They are here. You have the notes. Actually, I'm also going to post slides, but anyway, there is no need of posting slides. You can check the notes. Okay, and then summarize where you get confused. Come back to me. Okay, I'll always explain. I'll always explain. Yeah, even for biology, it is the same thing. Now for work, I usually post work, but I haven't posted for organic. But for inorganic, let me see if I have any lessons, any recorded lessons for inorganic. No, but they are there, but I haven't posted them. Okay, yes. Now don't watch for form 6. Don't watch for form 6. Now these ones are for form 6. Okay, don't watch for form 6. You watch for form 5. What is there? Lesson 6. Now this Lesson 6 is for. Anyway, you see, this one is introduction, then hybridization. I'm going to edit and put form 5 here and put form 6 here. I'm going to edit that. Okay? For clarity. So there is no reason why you shouldn't. What about inorganic chemistry? For inorganic, I recorded it, but I don't know if I have edited it or uploaded it, but it is also there. Okay? By the end of today, I'll try. However, it takes time to edit this video. And I can't just post. Now imagine I'm recording right now. I'm recording. Now, it doesn't make sense to post. Let me even